Okay, sorry, I started a little late on the recording. So it's y2 minus y1 over x2 minus x1. 20, oops, I went the wrong way. 16, let me erase that. 16 minus 24. That's 20 over 4, negative 8 is, divide by 4 is 5 over 2. Negative 5 over 2. Okay. And the units, want to make sure the unit is meters per second per second. Or you can write meters per second squared. Okay. Anyone else need me to finish up number 2? Any other parts of number 2 that you guys want me to work on? Okay. Let's look at number 3, graphical analysis. So they gave you a graph, we have to talk about the graph. So f being a function defined by the closed interval from -3 to 4, okay, we see a line and a circle from -3 to 4, with f of 0 being, so, okay. So f of 0 is equal to 3. The graph that's given is not f, it's the derivative of f. So it's f prime, consists of one line segment and a semicircle, okay? So just be careful. This graph here is not f, but this is f prime. Okay, so actually I want to spend some time talking about this right now. If this is f prime, this is the slope of f, okay? What is happening to the regular graph? What is happening to f here? Well, they told us f at 0 is 3. Can I write 1, 2, 3 here? So you guys can see that's 1, 2, 3. So at 3, is the change going to be positive or negative? Look at, this is the slope. And just tell me, is the slope positive or negative at 0? Would you be okay if the slope is negative? Negative, 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 0, still negative, 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 negative. So this is like my GameStop stock. I lose a lot of money, but I start to lose less, but I'm still losing. I'm losing less, but I'm still losing. I'm losing less, but I'm still losing. I stop losing. And then I start losing again. But as I keep losing more and more and more and more. So how does that graph look like? It looks like I'm losing a lot, and then I stop losing, and then I start losing some more. Okay, see, do you see how I stop losing? And then I start losing some more. What happens here? Am I losing? Yeah, I'm losing. So I had to be up here. I was up here losing. I was still losing, folks. Okay. I was losing a little bit, little loss, to fast loss. Right? Because I lose a little bit to I lose a lot. So hopefully you guys can follow along the way I'm drawing this. And then here I'm gaining, right? I'm gaining. So why would I be drawing it this way? Because reading from left to right, I am gaining a little bit, gaining a lot. I gained a lot, and then I gained a little bit. Then I stop gaining, and I start to lose. Okay, so that's what the graph kind of looks like in the F position. All right, so on what interval, if any, is F increasing? Okay, so you do not need to draw this. I just had time right now to help you guys see where this slope is taking us, where this journey is. It's like I'm being blindfolded. You ever see the kidnapping? They always put a blindfold on you, they put a bag on your face, and then you have to remember, I turn left, I turn right, I turn left. Sometimes they'll go make lefts. If a car makes the left 4 times, that probably means he's driving straight on his original path, FYI. Okay. On what interval is F increasing? Justify. So what does F mean that it's increasing? Means F prime is positive. We are positive here. We are only positive here. Looking at my version here, I'm losing money. This, if I was a business owner, this is my business, I was losing money this whole time. So this is only increasing when F between -3, and -2. That's when I'm increasing. Okay. And if you want, let me tell you this right now. The AB calculus test doesn't care if you this is probably the best, but the AB calculus is not going to worry about these necessarily. Okay. Because 0 is positive or negative, right? Okay. So, well, on the interval between -3 and -2, right? They claim that. Okay. Andrew, are you okay with that? First part?
I think so. Yeah.
Right? Because when something is increasing, you look at the derivative. So if they ask you about f increasing, then you look at f prime as positive. You look at the derivative of whatever they ask for. But what if they ask you, when is f prime increasing? What do we look at? Do we look at f prime, or f double prime?
F prime then?
No. Okay, if
Double
f,
prime, I mean.
what was that?
Because last time you said if you're looking at F, look if you say ask for F, look at F prime. So
Right.
would we be looking for F double prime now?
That's right. So if this guy is greater than 0, that's when we're increasing. So looking at our chart here, when is the only time f prime is increasing? Between what numbers? Can you see?
-3 to -2.
-3 to -2. Nope, nice try. Remember,
No.
f double prime is the derivative of f prime.
Oh yeah.
So when does it look like on this graph I'm actually going to be increasing?
Would it be from -2 to 2? All right, 0 to -2.
That's it. 0 to +2, I think. That's what you mean. You mean like this section
Yeah.
here, right?
Yeah, that section.
See, and that is right. We can spot a derivative just by looking at it, and that would be positive. That's the only place that f prime would be increasing. So whenever they ask you increase or decrease, you take the derivative of what the literally the word that they ask you about. Okay. If they say when is velocity increasing, take the derivative of velocity. When is acceleration increasing, take the derivative of acceleration. Okay. Let's look at part B. Find the x-coordinate of each point of the point of inflection of the graph of f on the open interval of -3 to 4. So point of inflection is second derivative. Okay, and they said because of second derivative of f, they asked us what is the point of inflection of f. So we have to take two derivatives of f, gives us f prime. So what is f prime double prime? Sorry, f double prime 0. So I want you to look here. When is f double prime 0 or doesn't exist? It is decreasing, 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 decreasing. Doesn't exist. Increasing, 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 increasing. 0 and decreasing. Okay. So hopefully you see that it's at x equals to 0 and x equals to, in this case, 2. Now, do we change signs? Yes, we go from negative to positive to negative. So we do change signs. So we do have a point of inflection. And they would say it in a nice way. They say like f prime changes from decreasing to increasing at 0, and from increase. So you have to tell them that they change signs. Okay, so you must, in the calculus, and on the AP test, you must say f prime changes signs. No, sorry, double prime changes signs. Changes signs negative to positive at x equals to 0 and positive to negative at x equals to 2. Okay, you have to actually tell them the sign changes. If you want to use their vocabulary, they say increasing to decreasing. If it's increasing, decreasing, that means I'm talking about f. F is increasing, f is decreasing. Okay, let's look at that part C. Find the equation for the tangent line of the graph at f at 0, 3. Okay, so they want the tangent line equation. How do I get the tangent line equation of f? So remember, f is what I'm looking at. So the way we get the tangent line is we take f prime is the slope. Great. Well, f prime, well, we have the slope. F prime is right here. F prime is -2. My m is equal to -2. Again, I'm just taking what they're giving me, remembering my basic rules. Line graphs, y equals to mx plus b. Better would be y minus y1 is equal to m, x minus x1. That's even better. My y is y minus 3 equals to x minus 0, and the m value is given automatically as -2. Okay, now let me tell you this right now. You're done. You don't need to solve for y. The arithmetic doesn't count on the AP exam. All right, let's look at the last part of this. D. Find f at 3 and f at 4. Show the work that leads you to your answer. Sure, okay. So how do we get from f prime back? We're going to take the integral. But let's take a look at the graph again. At f at -3, the -3 looks like a line equation, doesn't it? Here's -3. So if I could tell you what that derivative is, so y prime is equal to, the slope is, I don't know what the slope, but the slope is, oh, -1/1, right? Is that right? No. The slope is, what is that slope? Yeah, it's -1/1. The slope is -1/1. The y-intercept is -2, right? I'm just looking at the graph. And if you look at the graph, that's the equation of the line. How do I go backwards from it? We take the integral of this. We end up with the integral, sorry, not integral. We end up with -x² over 2 minus 2x plus c. We're going to go ahead and say, well, f of x is equal to this. Well, f of -3, oops. Oh, we also have a point, I'm sorry. We have a point of our, remember we have they told us f at 0 is 3. We're going to plug that in. So f of 0 is equal to -0 squared over 2 minus 2 times 0 plus c is equal to 3. Because that's our initial condition that they gave us. Great. As c is equal to 3. F of x is equal to -x² over 2 minus 2x plus 3. And we're going to plug in -3 for us. So it's -3 squared over 2 minus 2 times -3 plus 3. And then we're done. That's your answer. Remember, the AP calculus exam does not care about your arithmetic. Like I did that right? I don't know. Hope so. Okay, the problem with the next one is f at 4. If you look at 4 here is a circle. And I don't know if you guys remember how to do circles, but this circle equation is y is equal to, do you guys remember how to do circles? It's like x minus h squared plus y minus k squared equals to r squared. And the radius for this is 2. Our center of the circle is 2, -2. So it's x minus 2 squared plus y plus 2 squared. And then if we solve for y, this would be y plus 2 squared is equal to 4 minus x minus 2 squared. Take the square root of that. Y is equal to 4 minus square root of 4 minus x minus 2 squared minus 2. Y is equal to x squared minus 4x plus 4. negative. Huh, is there an easier way to do this? Oh, whoops. Another way is for them to actually just do the area. Uh-oh, whoops. Haha, hi, everyone. Yeah, you're smart. You're smart. Yeah, you're smart. I was like, I ain't taking the integral of this crap. Oh, you're smart. Gosh. Yes, area. Oh my goodness. I was like, so we know that this is going to be, f is at 3, right? So we're going to, what would that point be and what would this point be? Okay. So what is the area going this way? So that's 1 by 1. This is 2 by 2. So 1/2 base times height is 1/2. 2 times 2 is 4. 1/2 is 2. Negative 2. And we get to 3. So 1/2 minus 2. Let me see, how can I do this? Y is equal to, no, y, yeah, y minus y plus 1/2 minus 2 is equal to 3. That's one simple way of looking at it. I started at some value, and then I added 1/2, I subtracted 2, we end up with 3, because that's our final value here. So this is going to give us y is plus negative 1. One and 1/2. Huh. Uh-oh, that's not what they got. Equal to 3.
It would be plus the 1 and 1/2, so it would be equal.
Oh, thank you. So wait, it'll be plus the 1 1/2. So if I help me out here. Did me if I add 1 and 1/2 to both sides here? Oh, I see what you mean. Oh, I think I see what you mean. But right. So if I plus 1 and 1/2, we end up with y is equal to 4 1/2. There you go. That's it. Thank you. And then the second one is that's a circle, so we can find the integral. It's the integral of what is a circle? So a square minus a circle. So this is half a circle, and we're going to subtract half a circle off a square of 4 by 2. So 4 by 2 is 8 minus a circle, which is pi r squared, 2 squared. So it's 8 minus 4 pi. And then, sorry, over 2, which is 8 minus 2 pi. So it's 3 plus 8 minus 2 pi. So it's 3 minus, sorry. It's a minus because remember how it's all negative? 3 minus 8 plus 2 pi. Okay. Thanks for catching me there. And the last one was 5. 5D. Let's take a look at 5. Now 5, these table ones are, there's pros and cons, right? Pros are that they give you numbers. And usually they're going to ask you for rates. They're going to ask you for estimate the area underneath the curve. So as you can see, the first question here, A is, I wonder how come it's hard to see it. There it goes. Okay, so the first question is estimate what T prime is. T prime is just a slope of 7. Now for these types of questions, I need to say it's super easy because we don't know what 7 is, okay? So in this version, there's actually only one choice for us. We're gonna find 7 by using the points next to it. So it's just 55 minus 62 and 8 minus 6. And that's the slope. Because remember, when they use the word estimate, they don't want the derivative. We don't even know what the equation looks like. Okay, metal wire length 8 is heated at one end. The table above shows the selected values of the temperature T in degrees Celsius of the wire from the heated end. The function T is decreasing and twice differentiable. Okay, that means it's T, we know the derivative of T is negative, and we can see that decreasing and twice differentiable. So we know it's continuous. Okay, it's continuous and we can take the derivative of it. So no weird jumps. It's not gonna spike on us. Or do anything weird. And it's also going to be continuously decreasing. It's not going to go up and then down. Okay, write an integral expression in terms of Tx for the average temperature of the wire. Estimate the average temperature of the wire using the trapezoid sum using 4 subintervals. So they told us exactly which method they want. They want 4 subintervals. That's 1, 2, 3, 4. Now, let me tell you guys, when you guys are setting it up, you don't have to do the work. What I mean is, because this is the AP Calculus exam, they just care about the setup. They don't care about the arithmetic. So you could write 1/2. Let's look at an example of what is one trapezoid. Trapezoid 1/2. What the hell? 1/2 height B1 plus B2. Okay. So our first one would be 1/2 height would be, I would use from 0 to 1, and then 93 minus 100. Okay, that's my first trapezoid. Okay, the second trapezoid would be 1/2 height. It would be 4, and then it'll be 70 minus 93. Oh, sorry, plus. I'm sorry, it's plus. My mistake, plus. Okay, and then the next one would be plus 1/2. Height is 1 because 5 to 6 is 1, and we're going to add 70 plus 62 plus 1/2 height, which is in this case going to be 2 because 6 to 8 is 2, and then 62 plus 55. Now, do not do the rest of this problem. You're done. Okay. So that's us adding up the area underneath it. Now estimate the average. So you can just draw this big old division sign over everyone, this big old line, and say the 8 minus 0. Okay. What they did in the answer sheet, they just call this all A. They said A is equal to this whole line. And then they wrote A divided by 8 minus 0. And that's the average. And that's perfectly fine. You can actually call whatever variables you want to use and then rewrite them later. As long as you label it, the reader will understand what you're saying. But again, if you just wrote everything divided by 8 minus 0, that's also 100% okay. Just make sure you label it, the answer as, if you use A is for area or A is for average, make sure you write it out so it's very clear which one you're going to use. Okay, find the integral of t prime and then indicate the value measured. Okay, so what happens to an integral and a derivative? What should they generally do to each other? They should cancel each other out, right? So we should end up with just t plugging in from 8 minus t of 0. Okay, that's really what they want. And we can just look at those numbers on the table. So what happens in this time? What is the sum of the changes? So that's just the change of the temperature. Last one, D. The D looks like, let's see, are the data in the table consistent with the assertion that T double prime is greater than 0 for every X on the interval between 0 and 8? Explain your answer. So what does T double prime refer to? Whenever we look at the second derivative, we refer to concavity. So are we saying this is concave up, right? Because it's greater than 0, that means it's concave up. Well, let's see. are we always concave up in this? So concavity refers to the derivative of t prime. And then the derivative of t prime is, so if you look at t to t prime, this is our slope. And t double prime, let's look at a picture actually. If I look at something that's concave up, okay, we were told that this graph is decreasing. So if t is decreasing, that means this graph is always going down. It's always going down on this side of it, okay? So if it's always decreasing, how do we end up with something that might be concave? So if I look at a graph, if I give you guys a decreasing graph, it could look like this, or it could be looking like this. Now, if it goes negative, less negative, 0, less negative, super negative. But if it goes negative, 0, up, this is negative to positive. I'm trying to figure out how I could look at the data. The data in table set with assertion that it is concave up for every interval. Is it concave up? And they're saying okay, so this is concave down. Derivative is decreasing, stop increasing, concave down. Trying to think of a way to work this. Concave up is when the second derivative is greater than 0. And we know that this for sure is less than 0. How do I know? How do I break the rule? How do I know that something is increasing? Concave up is increasing. So I have to be, okay, so if something is concave up, that means it's slowing down its loss. Is that right? It's slowing down its loss. So concave up means my acceleration is positive. So even though I'm decreasing, I should be not decreasing even more. Okay, that makes sense to me. So if I am driving my car forward, right? I'm going forward, but does it mean I'm speeding up? No, I could be slightly braking, but I'm still going forward. For us, this graph is slowing down. Sorry, it's going down, it's losing temperature. The graph is losing temperature. That's our idea. If it was concave up, it wouldn't be increasing temperature even more. It would be increasing temperature, but slowing down its loss. Okay. So what we're going to do is we're going to compare, are my slopes becoming more negative or less negative? Am I going to be experiencing more loss, or am I going to be experiencing less loss as time goes on? Okay. So we're going to pick some values and we're going to see what happens. So they used 5 and 70 and 0 and 100. And they said, okay, what does our loss look like here? So 100 minus 70 over 0 minus 5. Our loss is 30 over negative 5 is negative 6. Well, what's our loss look like between 5 and 70 and 8 and 55. What does that look like? 55 minus 70 over 8 minus 5 is 15, negative 15 over 3, which is negative 5. No, it looks like it's becoming less, but they chose specifically, they went through and they said, they said 5 and 6. They said, let's try 6 and 62 and 5 and 70. 70 minus 72, or 62 over 5 minus 6, and this became negative 8. Oops. 70 minus 62 and 5 minus 8 is positive 8 over negative 1. So if you look here, that's actually an increase in loss. So this here shows that at some point we had positive acceleration. So we got even worse. So to be concave up, you are slowing down your loss. But we actually slowed down and then we had to drop someplace. So that's what the answer is trying to say, that because we actually increase in our loss, that means there's had to be some time in X where T double prime was greater than 0, because we actually, no, less than 0, because we gained a lot more loss at some point. So let's see what due to the mean value theorem, that T prime is negative 0.57 and that is 8, some C row, that means the following: T prime decreases somewhere is not positive for every value of X. Okay. So that's what they did. And I'm pretty sure that almost no one got that answer right. So that was
Mr.
one of those
Ko,
hard ones.
I think class is over. I'm sorry to interrupt.
Oh yeah, thanks. Sorry. But yeah, but that's how they did it. I would have guessed that no one got that answer right that year. But I can look it up. But that was a tough question. But good question, but that was a tough question. Well, what they did is they asked you to just compare. If you look at the graph from looking at the table, you're supposed to somehow see that the loss, if it's concave down, that means you have to keep losing less at every step. And at one point, you actually lose more. That means you're concave down at some point. Okay, and that's what I was referring to. Want me to explain that a different way? Haruka, explain a different way?
No, I think I get it.
Yeah, because if it's concave up, that means even though we're losing less at every step. But if we're concave down, we actually end up losing more at every step because we're concave down. So we're comparing at, if we're losing only like, let's say 0.6 and 0.5, when we lose 0.8, we're like, oh crap, we went from 6 to 5, then back to 8. That means we actually lost even more. That means we're concave down at some point. Okay. If you guys have to go, you guys can go. Sorry about that. You guys can go to your advisory. Bye, guys. But yeah,
Thank you, Mr. Ko.
Yep, see ya. But that part was tricky. I was like trying to figure out how am I supposed to prove that. If you're given a graph, you can prove it by seeing that it had turned around, like you lost more. Concave graphs are always bowl up. Even if it's part of it, it's still slowing down. See, I'm slowing down my drop. It's like a roller coaster. You fall the most and you're getting less and less falling. But concave down goes down this way. So you could be negative slopes, but see how the slopes became even worse every step you take. So our graph here went from a certain slope and all of a sudden it sloped even more. That means though it was concave up, at one point it became concave down for a moment. And the way they did that was by just showing the slopes between each of the data points. But I have no clue how you were supposed to figure out 5, 6 was supposed to be the one that was bad. So that's a messed up question. Especially if we only have 15 minutes. Okay. All right. Kind of okay now? Makes more sense. Yeah, this one was probably not a big hit that year. Tell you that right now. Yeah. Okay. Thank you. Do you have any other questions?
No, thank you.
Oh, sorry about the long day. Bye.
Bye.
Anyone else have any other questions I can cover? Can you also do it by adding the area of the integrals? Adding the area of the integrals. Adding the area of the integrals. That would be the integral of t, and that doesn't prove that the second derivative is concave down. Oh, so that's a different question. All right. Bye, guys.